Okay, so as we go through here and we talk about our probabilities and different things, we're going to now encounter something called conditional probability. Very common, very useful. And so at the top, I have defined what conditional probability is. So again, you're watching the video, print out or open up the PDF on your screen of the sheet that we're going to follow along with here that I typed up. Conditional probability says the probability of an event E2, the little subscript there is just telling you it's a second event. The probability of event E2 occurring given that event E1 has already happened. Okay, so E1 is given information. I know that that has already happened. That's called conditional probability, and it's notated like this. So this is the probability of event E2 given that. Okay, so when you're reading this, you just say that the given, that bar you read as given that. The probability of event E2 given that even event 1 has already happened. You know it's happened. Okay, this is called conditional probability. So example 1. Goes like this. A single card is selected from a deck of cards. Okay, so we're back. We just have one trial going on here. Determine the probability as a club, given that it's black. Okay, so we're going to find the probability that the card is a club, given that I know it's black. I'm going to help you with this. I'm not expecting you to be doing anything. I just want you to write this down and just make sure everybody's caught up. Okay, the first couple examples will be where you learn stuff, and then we'll iron out the details with the other examples. So here's how I'd like you to think about conditional probability. When we first defined probability, we said that probability is successes divided by your total number of outcomes, right? So when we were just doing the DVD problem a minute ago, there were 7 DVDs and 4 of them were dramas. So the probability of finding a drama was 4 successes out of 7 total possibilities. Okay, so when you do conditional probability, we know the card is black, right? So this, the given information, this becomes your new total number of outcomes. So, exactly, great observation, not using 52. In fact, if I'm finding the probability of a club, given it's black, how many black cards are there? That's my new total number of outcomes. I'm only considering the black cards now, because I know, I've been told, somebody is looking over somebody's shoulder and said, the card's black. Okay, so we know the card is black. That's given information. So now, out of those 26 black cards, how many of them are clubs? 13. So now with that given information, you change the probability. Instead of 13 out of 52, instead of being a 1 out of 4 chance that you drew a club, now that you know that it's a black card, the probability becomes a half. Half the time, if it's a black card, if you're just limiting yourself to that, it's 1/2. Just to make mention of this, again, the thought process, what if I said, what's the probability that it's a heart, given that it's black? I just want to make sure that we're going along with this. So again, black cards, I know it's black. That's my new total number of outcomes. How many black cards are there? 26. Out of the black cards, how many hearts are there? 0. Okay, so make sure that this is my new total number of outcomes, but I've got to make sure things are aligned. So how many hearts are there in my black cards? There are 0. Okay, so yeah, so that's why I want to do this example. It's not, I know there's 13 hearts in the deck of cards, but I know it's a black card. Okay, so I'm only limiting my thought process now to the black cards. And the black cards are the spades and the clubs. There's no hearts. The hearts are red. Okay, so that's why it's 0. That can't happen. If you know the card is black, then it can't be a heart. Does that make sense? Okay, so that's 0. All right, do the example 2. Determine the probability it's an ace, given that it's a number card. And remember, we're counting aces as numbers. We're counting an ace as 1. Okay, the numbers are 1 through 10. All right, so ace, given that it's a number card. So I'm telling you, we know this. The card that we're looking at is a number card. How many number cards are there in the deck of cards? There's 40, 1 through 10, ace through 10, and then there's 4 suits. So there's 40 number cards. Now, limiting myself to just those 40 cards, how many of those cards are aces? So that would be a 1 out of 10 chance. Again, just to make sure we're thinking about this right, what's the probability of a king given that it's a number card? Well, again, there's 40 number cards. So limiting myself just to those 40 number cards, how many of them have a king on them? None. The king's a picture card. It has no number on it, so that can't happen. Once you know that it's a number card, you cannot get the king. Okay, that's conditional probability. Let's look down example 3. Example 3, I give you 6 circles of different colors with different numbers in them. And there's 3 questions. We're going to take them one at a time. The first question, the A question, is just a straight probability that we've been doing since section 11.1. So this is example 3. If you're following along on the video, the A problem says, what's the probability that if I choose one of these circles at random, that it's the 5? Okay, so take a moment. That's just straight probability. There's nothing conditional about that at all. Probability of 5. Mm-hmm. Okay, so there's no condition. It's just I'm looking at all of them. So how many total outcomes are there on this? 6. And out of those 6 outcomes, how many of them have the number 5 printed on them? 1 out of 6. Yes, that's just straight probability. That's section 11.1. Okay, going way back to the beginning. Okay, B. Now, this is conditional probability. The next problem I would like you to take a moment and think about is what's the probability of a 5, but now, given that I know it's an orange circle. So take a moment. Given that it's an orange circle. All right, so my given information is orange circles. How many of the circles are orange? 3. And now you can just use your thumbs, cover up everything else. Out of those 3 orange circles, how many of them have a 5 on them? 1 out of 3. Great. Do the next one. What's the probability it's an even number given that it's not orange? Okay, probability of an even number given it's not orange. All right, so in my circles, how many not orange circles do I have? 3. There's two yellows and a green, so there's 3. So again, cover up the orange ones. I don't care about them. I only care about the not orange ones. Out of the not orange ones, how many of them contain even numbers? 2. There's a 2 and there's a 6. So 2 out of 3 chance. Excellent. All right, we've got like 3 minutes. We're just going to do a couple more problems, and then we'll put a pin in it, and you can finish this sheet. You know everything you need to know about conditional probability. And we'll finish these examples up next time. We're going to look at the following table. The table shows the level of patient satisfaction with their surgery for different types of surgeries. Okay, so first one, this is example 4. We're going to just try to do the first couple problems, and then we will call it a day. The first one is just a regular probability. So what I would like you to do is, using the table, what's the probability that if I randomly select a patient that they are satisfied with their surgery? Don't be silent. I love your enthusiasm. Okay, so probably that they're satisfied. Well, first, how many total people do we have in this table? There's 250. Down in the bottom right corner, it says there are 250 people total represented in this table. And out of those 250, how many of them were satisfied with their surgery? 210. That's the satisfied column. At the bottom, it says 210 out of 250. I'm just going to divide both those by 10. That's 21 out of 25. Or if you made a decimal out of it, it's 0.84, I believe, is what you're looking at. So we're going to do one more problem just in case. I want you to be able to do the homework. And if you're still confused about reading the table, then we're going to do more problems next time. So what's now the probability they're satisfied given they had knee surgery? I'm going to give you 30 seconds to make as much headway with this as you can. Then I will follow up, and then we'll be done. Just so that I let you out on time, which is always my promise to you. Remember the given information. This is our new total number of outcomes. So how many people had knee surgery? 95. Now, if you're confused about where to look, take your hand, cover up everything except for the knee row. Okay, because the knee row is all I care about right now. And in the knee row, I'm sorry, in the knee row, how many people are satisfied? 75. So 75 out of 95. And so then you reduce that by 5. 5 goes into 75 15 times. 5 goes into that 19 times. And there you go. I hope you all have an amazing rest of your day.